Good morning, everyone, and welcome to SAT Prep. Today we're going to go over the rules of exponents, which you should probably already know, but let's review them. Okay. There will be a total of 7 rules to go over today, and then we also have to talk about how to reduce radicals. Basic rules of exponents, all right? If you have x to the a, so some base to a power, times that same base to another power, what do? You add the powers together. So it's the base to the a plus b power. For instance, 10 to the third power times 10 to the sixth power equals 10 to the 6 plus 3 or ninth power. There's your first rule, and it's a very commonly used one for this unit. All right, so same base, different powers, or even the same power, doesn't matter, but same base, you write the base one time and you add the powers together. Let's move on to the next example, the next rule. We have a base x to a power a, all raised to another power b. What do? The base stays the same, it's still x, and the power is their product, a times b, whatever that is. Okay, so 3 squared to the 4th power is actually 3 to the 8th power because 2 times 4 is 8. So far, so good. I'm not going to belabor the point too much and have thousands of examples on each example, or each rule, because these are things you probably already know. Let's move on to the next of our rules. So we have the first two done. Here's the division rule. If I have a base of x to a power a, and it's being divided by the same base and another power, we're going to write that base one time, it's x, and just like multiplication led us to add the powers, division is going to lead us to subtract the powers. So it's the power in the numerator, a, minus the power from the denominator, b. So again, 3 to the 4th power over 3 to the, let's say, I'll keep it positive right now, but 3 to the 3rd power is 3 to the 4 minus 3, which is 1, which is just 3. There's a rule there. I took too much room for that, so I have to now erase again, but there's our third rule. Okay, the next rule, if I have a quantity in parentheses, I'm going to make it two different variables now, x over y, and it's all getting a power of a. That means that the numerator gets the power, and so does the denominator. Okay? Similarly, if I have a base of multiple variables in parentheses with a power, that means that each piece of the base gets the power. So if it's in parentheses, whether it's a fraction or whether it's a product, each piece will get that power. Moving on again. This one is actually pretty easy. Anything to the 0 power equals 1. It does not equal 0, it equals 1. Anything to the 0 power equals 1. X to the 0 is 1, 5 to the 0 is 1. Anything to the 0 is 1. What about negative powers? This one is always tricky for a lot of people. A negative power does not make anything negative. A negative power is an instruction that tells you to invert or flip your base. So the base was x, so now it's 1 over x. It flipped upside down. And now that I flipped it upside down, the power of x is just positive a. Let's have an example for that one. Let's say it's 4 to the negative 2nd power. That is 1 over 4 to the 2nd power, which is 1 over 16. So a negative power will take the base and flip it upside down. If it was already a fraction, the fraction section flip over. For instance, one more example of this one. Let's say we have 2/3 to the negative 2nd power. That means that the negative part flips the base upside down, and now it's a positive power. And now because we have a quotient in parentheses, the numerator gets the power and so does the denominator. And that means the answer is 9/4. All right, so we used more than one rule just now. We used the rule of the negative power, and we used the rule of the values in parentheses, and then we resolved the problem. Okay. One more thing, which was something I believe you learned in Algebra 2, which is a rational power, which is a fraction in the power. So, x to the a over b power. Here's what that really means. A fraction power is actually a kind of root, whether it's a square root or cube root or some other variety of root. It is a root function. The base is still inside the root. The numerator is the power of the base. The denominator is the kind of root that it is. So that's what happens when you have a rational exponent. You have to translate it into a radical expression. For instance, let's say it's 5 to the 2/3 power. That is 5 under a radical, square root. Well, not a square root this time. It's actually a cube root because it's the third root of 5 squared, which is the third root of 25, which is a decimal, so it does not reduce further than that. Well, that brings us to reducing radicals. Let's talk about how we reduce a radical. Start off with an easy radical, the square root. All right? I'm going to use, let's say, square root of 40x to the third power. How do you reduce a radical? You're going to break down the number and also the variable into its prime factors, its component parts. It's not that hard. We use a little tree diagram. 40 is really 2 times 20. 20 is 2 times 10. 10 is 2 times 5. And the 2 and the 2 and the 2 and the 5, they're prime factors. They don't break down to anything other than 1 times themselves, which we do not write. These are the prime factors. X to the third, we're just going to write 3 x's. It's easy enough. Now, we're looking for the square root. So we're looking for prime factors that have pairs. Here's a pair of 2 2's. So I'm going to write down the number 2 to represent them. Here's a pair of 2 x's. So I'm going to write down an x to represent them. This 2 and this 5 and this x have nowhere to go because there's no pair. So I'm going to write the radical again, and I'm going to put them back in. 2 times 5 times x. And now I'm going to reduce this. 2 times x, of course, is 2x. 2 times 5 times x is 10x. This is how the radical reduces. And again, it's because you're looking for prime factors that recur in the same frequency as the kind of root. It's a square root, so we're looking for things that occur in groups of 2. Leftovers stay under the radical. Let's do another one. We'll do the third root of 64x to the 5th. So, 64 breaks down. You could do 8 times 8. There's no problem there. Each one of these 8s is 4 times 2. Each one of these 4s is 2 times 2. 2, 2, 2, 2, 2, 2. They're all 2's. They're all prime. The x to the 5th, well, that's just 5 x's. That's what x to the 5th is. Now, it's a cube root, so I'm looking for things that occur in groups of 3 this time. So I see 3 2's. I'm going to write the number 2 down. I see 3 more 2's. I'm going to write another 2 next to it. There's no leftovers because nothing was unpaired. The 8's and the 4's broke down, so they don't exist anymore. It's just the prime factors we care about. I do see a group of 3 x's, so there's an x there. But these 2 x's have nowhere to go, so there's still a third root, and it's x times x goes back in. 2 times 2 times x is 4x times the third root of x squared. Now it's fully reduced. I believe you've already done this in former classes, so this should be a review, but not brand new information. Okay. that's the new content for the day, or at least the review content for the day. And I'm going to give you time right now to work on the attached homework, which is only 5 problems that has to do with using the rules of exponents and radical reduction. Give me an email or some sort of contact if you need help. If you want to do a Google Meet, which I'm more than happy to do for the whole class or just individuals, let me know and I'll help you. If you need more help with the IXL tasks from the other day, let me know and I'll help you. Either which way, let me know. I will probably have the Google Meet active today between, let's say, 7:30 and 7:45. If no one logs in, then, it is what it is. I'll just cancel it. But if you want to log in with questions, feel free to do so. Okay? Otherwise, have a great day and let me know if there's any problems.